So, good day everyone. So let's discuss again for the analysis of indeterminate beams. But in this topic, I'm going to use the slope deflection method or SDM na tinatawag. Okay? Okay. So slope deflection method or SDM is a method that was originally developed by Heinrich Manderla and Otto Moore. It is for the purpose of studying secondary stresses in trusses. But later on, in 1914, George A. Maney developed a refined version of this technique and applied it to the analysis of indeterminate beams and frames. Okay? Ulit. So, nakadevelop siya ng isang equation wherein we can solve for the moments as well as the slope and deflection in at a certain point. So kaya siya tinawag na slope and deflection method for indeterminate beam siya. Okay, so it is given by itong formula na to. Okay. Okay. Wala. Okay, so this equation is given by, so Mn ibig sabihin, Mn is the internal moment in the near end of the span. This taken as, so for this topic, it is taken as positive clockwise. Okay, so considering this figure, ang Mn natin dito, considering at point A or AB, ito yan, MAB. Okay, and then ang next naman is for is equal to FEMN. So FEMN, N ibig sabihin the fixed ended moment at near of this moment na kinukuha natin, and then plus 2EI over L. So EI is the flexural rigidity and L is the length of the span times 2 theta N plus theta F. So again, yung mga subscript na yan is N is indicating near, and yung F naman ibig sabihin far. Okay, and then for this so ang tawag dyan is psi. It is given by this formula. Okay, so it is the support settlement. Okay, so psi is a span rotation of its core due to a linear displacement. That is, so ito yung given na formula. This angle is measured in radian and is positive clockwise. Okay, so yan lang ating gagamitin for the slope deflection method. Kailangan nyo lang kabisaduhin to. In fact, madali na lang yan. Okay? Kahit hindi nyo na kabisaduhin. So, yan lang yung formula na gagamitin natin for this video. Okay? So, to better understand this problem, this method, syempre, magsasolve tayo ng problems. Okay? Ayan. So, we have the application of slope deflection method with unsettling supports. Okay? So, lagay ko muna siya sa sa drawing board ko. So, in here, may ready-made na ako na solution for this problem. So, di-discuss ko na lang siya, okay? Para mas madali tayo. Okay? So, first things first is to solve for the fixed-ended moment since meron tayong indeterminate beam na given, okay? So, saan yung pointer ko? Okay, so, ayan. Okay, so lang. Ayan. Okay, so solving for FEMAB, AB muna. So ito yan. Considering span AB, so AB, yung moment dito, which is considering ito, and then ito. Okay, span AB muna. So, since meron tayong dalawang concentrated load, so i-consider ko muna yung 15 kN concentrated load. So, PAB squared over L squared lang yan. Okay, we have the concentrated load 15, the A distance from the left support, which is 2, and then the B distance 6 squared all over 8 squared, plus yung second na concentrated load which is 12 kilonewtons times yung A distance which is 5, and then yung B distance which is 3, and then squared over the total length which is 8. Okay, and we will arrive with this answer. Okay, 25 negative 25.3125, since ang assumption natin dyan is that sa moment at AB is counterclockwise. Okay, so clockwise positive, counterclockwise negative. And then we have this fixed-ended moment at BA. So, 15 na concentrated load. Tapos, yung A naman natin yung E squared. Okay? And then B all over the total length squared plus ganun rin sa kabila, which is the 12 kilonewton load. And ganun lang din. And then, we will arrive with this answer. Okay? And then, for the next end moments, we have this fixed-ended moment here. Okay, so we have a fixed-ended moment considering span BC. So FEMBC is equal to, since uniformly distributed yan na span to span, so pwede natin siya gamitan ng shortcut, which is just WL squared over 12. Okay, for uniformly distributed span to span. Okay, so we have 6 na uniformly distributed load times the total length which is 11 squared all over 12. So we will arrive with this answer, negative 60.5, since ang assumption natin dito is counterclockwise siya. Okay? And then for the other fixed end moment, so magkakaroon tayo ng equilibrium dyan. So yung ating moment dyan will just be the opposite of our FEMBC, which is equal to 60.5. Okay? And then after solving for the fixed-ended moment, we will proceed with our slope deflection equation. So, yan. First is to establish the slope deflection equation for each span. Okay? So, for span AB, as you can notice naman siguro that the supports A, B, and C are on the same level. Hence, wala tayong support settlement dyan or psi. So, ang psi natin is equal to 0. Therefore, yung ating equation will only will only look like this. Okay? So, FEM N or yung near plus 2EI over L times 2 theta N plus theta F. Okay? So, ayan yan. So, AB is equal to the fixed-ended moment at AB plus 2EI over L, and then 2 theta near. So, yung theta near natin is near A, and then far from B. Okay? And then, for moment BA naman, we have the fixed-ended moment sa near, which is near sa B and malayo sa A. And then, for the theta naman, so theta near, ang near na theta is the slope at B. Okay, plus theta far, which is the slope at A. Okay, so span AB pa lang yan. And then, ganun rin sa span BC, we add the fixed-ended moment plus 2EI over L times 2 theta near plus theta far. And then, ganun rin sa CB. Okay, so we will arrive with this following equations. Okay, and then, as you can notice, that the support at our end sa span, which is a fixed support, therefore our slope at A and C must be equal to 0. Okay, and then after that, so ito na yung final na ito na yung moment na final. Okay, so ito yung simplified na. Okay, so moment at AB. So, ito na equation doon, ito na equation doon, ito na equation doon. Okay? So, tinanggal na natin yung theta C and theta A. As you can notice, walang theta A and theta C dyan. Lahat ay theta B. Okay? And then again, makikita nyo dyan sa note, at supports connecting two or more span, the sum of the end span moment is always 0. Okay? So, ang ibig sabihin lang niyan dyan is if we have a simply supported at the middle span, we know that the moments dito, ito, ano, okay, pwede yan. Ang moment dito and moment dito is just the same value. But since they have different sign, therefore, kapag pinag-add natin yung dalawa, we can only achieve equilibrium or magzi-zero siya. Okay? So, hence, we will arrive with this concept, okay, that the supports connecting two or more spans or the middle support or at mid span. So yung moment, internal moment doon, 'di ba dalawa 'yan? We have the moment sa kabilang span and the moment sa kabilang span. Same value but different in signs. So therefore yung concept diyan magiging 0 lang. So since we have this moment dito which is MBA and then MBC, so equate na lang natin sila sa 0. So, MBA plus MBC is equal to 0. And then, input nyo lang lahat yan. Okay? So, we will arrive, since isa lang naman yung unknown dyan, which is EI theta B, we will arrive with this answer for EI theta B. And then, our slope, therefore, is equal to 33.255 over EI. Since it is positive, therefore, the rotation of our slope at B is equal to is in clockwise motion. Okay? Ayan. And then since EI theta B lang pala yung hinahanap in this equation, yun lang pala yung wala. Therefore, we can substitute EI theta B in our equations. Therefore, we can now say that the moment at AB is equal to negative 17 kilonewton per meter and moment at BA is just 36.315 kilonewton meter. And as you can notice, ang moment sa BC is negative 36.315. Therefore, tama yung ating concept kanina that the internal moments BA and BC is just equal but the same opposite in their signs. Okay? And then for moment at CB naman, we have computed as 72.6 or 59.3 kilonewton meter. Okay? Kung gusto niyo i-browse ulit yung problem dito or to check if tama ba yung sagot is meron dun sa past video ko. So ginamit ko lang din tong problem na to. Okay? But using MDM. So, double check nyo na lang kung tama ba yung ating end computation. Okay? So, this is only for example number 1. So, kung medyo mabilis, siguro may kinalaman na yun yung prepared answer ko. But, it saves time and it really saves time. Okay? So, kung nabitinan kayo, therefore, magpapos ulit ako ng other examples. Okay? So, kung di nyo naiintindihan, slow mo nyo na lang. Okay? So, that's it for my first example for using slope deflection method in indeterminate beams. Okay? Thank you and abangan nyo pa. Okay? Bye-bye.